Okay, now that we have worked on these sine graphs and we feel pretty comfortable with the idea of uh, changing the amplitude and changing the period, I need to expand the idea. And so this is the second video in this series, and we'll call this graphs of sine and cosine with shifts. And if you look at this equation, we have expanded. This is where the equation was, y equals a sine bx. So you notice I have added a plus c plus d. Now this is the most complicated equation that you can ever have, and so I want to begin by labeling these parts. A is the amplitude, no surprise there. Amplitude is the absolute value of A. B is used to determine the period. The period is equal to 2 pi, which is the normal period of sine, divided by B. Now, we want to discuss two new features in this equation now, and the first is right here. This is your horizontal shift. And your horizontal shift, notice the presence of the parentheses. This is just like we have had in our other functions. And the horizontal shift will be defined as C over B. Now that's the same B that we used to find the period. So B is going to play two parts in this drama. And C over B is the horizontal shift, and it is contrary in direction, just like it is in the other functions we've studied. So if it says plus, you're going left. If it says minus, you're going right. And finally, this plus D that you see right here, this is a vertical shift. And vertical shift, if it's plus, it's going to go up, and if it's minus, it's going to go down. Now, I want to take each of these separately, and then I want to throw it all together, and this is going to take some practice, so I want you to be patient, and we'll get through this. The first graph that I want to look at is one that has just a vertical shift. So that's the easier of the two. Let's look at y equals 3 sine 2x minus 3. Now, first thing you notice is that we're going to label the parts of this graph. This is A, this is B, and this is D. Now, how do I know that's that's D and not C? Well, the first thing is, do you see how you don't have any parentheses in this equation? And I know that sounds silly, but for now, that'll be enough for us to remember. We'll see in the next example when I actually do a horizontal shift, you'll see that there's something else about this that's unusual. So let's write down our information that we know. Our amplitude is 3. Our period is 2 pi divided by 2, so it is plain old pi. And we have a vertical shift down 3. Does everybody see why it's down? Because it says minus 3. So let's go through the process that we're going to go through. Let's say we want to graph one period of this. So we're going to go from 0 to pi. We're going to half that, pi over 2. We're going to half it again, pi over 4. We're going to multiply this point times 3 pi over 4. Now our period is laid out for us. This is a sine curve, has an amplitude of 3 and negative 3. We're going to cross at the beginning, middle, and end of this graph. We would go, it's a positive curve, so it would go up first, so it would look like this, and then down to the low point, so it would look like that. Now, that is our first attempt at graphing 3 sine 2x. Now we want to do the vertical shift. And after you get the graph done, what you want to do is you want to drop each of your major points down 3. And this is just a matter of subtracting, so I'm going to extend the y-axis down a little bit. All right, now this point 0 is going to drop down 3, so it's going to drop to negative 3. This point 3 is going to drop down 3 to 0. 3 minus 3 is 0. You see, you're just dropping them vertically. This 0 is going to drop down to negative 3. This negative 3 is going to drop down to negative 6. And this 0 is going to drop down to negative 3. And so here is our new curve. and it has been dropped down. Let me show you. I should put a -6 on here. And when you do this, you might want to indicate that this is the final, so that I'll know which one to grade. So that is a vertical shift. Now, you can have a plus or a minus here, and also remember that this vertical shift could be stuck here at the end, but it could also appear at the beginning of the graph. It's just a constant. Okay? Vertical shifts tend to be much easier than horizontal shifts. Let's do a horizontal now. All right, here's our graph. Y equals 3 sine. Now here are the parentheses. 2x plus pi. And that's your graph. Now let's label. First of all, this is A, this is B, and this is C. There is no D. Notice the C is inside the parentheses with the X, and that's the main thing you're going to see. It's not a constant. It's actually affected inside the parentheses like horizontal shifts for other functions. Now let's write our information down. Our amplitude is 3. Our period is 2 pi divided by B, which is 2. So our normal period is pi. And our horizontal shift is pi C over B, which is pi over 2. And let's go ahead and put a direction on that. It says plus, so we're going to go left. Now when shifting horizontally, it's a good idea to go ahead and graph the function without the shift and then shift it. So I'm going to draw like this. And here we go with our first glimpse of the graph. We want a period of pi, so let's go 0 to pi. Don't scrunch it up too much. Let's half pi, pi over 2. Let's half it again, pi over 4. And let's multiply by 3, 3 pi over 4. The amplitude is 3, so let's go up to 3 and down to -3. And let's just sketch in one period of this sine curve. So it would cross here and here and here, and it's positive, and it's going to go down here. Now, watch what I'm going to do. I'm just going to dot this curve. Now, that is one curve of y equals, or one period of y equals 3 sine 2x. Now I'm ready for the shift. I'm going to shift this curve pi over 2 units to the left. And my first question is, how far is pi over 2? Now, if I'm lucky, I can look on my graph and I can see how far is pi over 2. And here's pi over 2 right here. So this much, 2 of these little marks, is pi over 2. So basically, I want to move every dot on this graph, and I can just move the big ones. I want to move each big dot, there are 5 of them. I want to move them 2 dots, 2 marks left. So I'm going to mark 2 marks over here, and I'm going to do this in red so you can see it. I'm going to shift this dot over 2 and put it right there. I'm going to shift this dot over 1, 2 and put it right there. I'm going to shift this dot 1, 2 and put it right there on top of that one. This dot 1, 2 and put it right here. And this dot 1, 2 and put it right here, so that this becomes my shifted graph. Now again, this is only one period, and that's all I'm asking you to graph right now. We might graph 2 periods as we get along. There is one thing that's missing from this graph, and that is, you remember I told you that I gave you points for points. I give you points of credit for these marks that are labeled, and there are no labels over here, so I need to label these. So what I need to do is I want to say, well, that's pi over 4 on this side, so this is a negative pi over 4 right here. And this is pi over 2, so this is a negative pi over 2. They're reflected across. So you would be getting credit for this 1, 2, 3, 4, 5, 6, 7, and then the whole shape would be 8. There'd be probably 8 points of credit to this graph. So this is a horizontal shift. All right, in my final example on this video, and we're going to drill in class both working on charts and then also on graphs. Let's combine these two ideas now. Let's look at y equals -2. I'm going to do a cosine just because we've been doing all signs. Cosine, parentheses, 3x minus pi over 2 plus 2. Now this is a very complicated graph. So let's just, first of all, let's take it apart. Let's label the parts. This is our A, this is our B, this is our C, and this is our D. So this graph has got everything. Let me pull it over just a little bit and let's label some of these changes. All right, so the amplitude here is 2, and it is negative. The period is 2 pi divided by B, which is 3. 2 pi divided by 3 is an unusual period. The horizontal shift is pi over 2 divided by 3, which is pi over 2 times 1/3. Let me go ahead and write that here for you, which is pi over 6. So we're going to shift it pi over 6. It says minus, so let's go ahead and put that we're going right. Pi over 6 right. And then finally we have a vertical shift up 2. Now that's pretty complicated. So let's take it step by step. All right, here we go first. Let's lay out a period of 2 pi over 3. So that's going 0 to 2 pi over 3. And half of that is 1 pi over 3. And half of that is pi over 6. And times 3 is pi over 2. Okay, I'm going to kind of check this off as I go. Okay, amplitude is 2, so let's go up 2 and down -2. So we've now taken care of the amplitude. Now I'm going to take this pen and I'm just going to dot in what the curve would look like if that's all we were doing. And it is a negative cosine. So remember, it crosses at the second and fourth points. It's high in the middle. It's low at the beginning and end. It's like you turn the bowl over. So this is what it would have looked like without the shifts, if it had just stopped right there at 3x. Okay, now let's go ahead and shift it pi over 6 to the right. Now I have to look on my graph and see how much is pi over 6, but I'm lucky. This much is pi over 6. So it looks like to me if I just move all the points over 1 notch, I'll have it shifted. So let's do that. This point is going to go to here, pi over 6. This one is going to go to here, pi over 3. This one is going to go to here, pi over 2. This one is going to go here. And this one is going to go to an unknown point. And so what I have to do is go back up here, extend my line a little bit, and put a mark there. Now, remember I told you to figure out what that is. Go to your very first point, which is pi over 6, and then count by pi over 6's. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So this unknown point must be 5 pi over 6, and you have to label it. I'll be looking for it. Okay, now I'm going to make this also dotted, but I'm going to make it a little bolder. And now I've done the horizontal shift. Okay, now I have drawn it, I have done the period, I have shifted it to the right. I'm ready now to pick the whole thing up to, and this will be my final graph. So what I want to do is, instead of going from -2 to 2, this graph is going to go, everything is going to move up 2. So take this point 0, or this point here at pi over 6, -2, and pick it up 2, that is, put it right here. And I'm going to draw this in heavy green. Pick this one up, pick it up 1, 2, and put it right there. This one isn't 2, it's going to go up to 4, and I need to extend this axis. This one at 0 is going up to 2, and this one at -2 is going up to 0. And here is the final graph, and you could even write the word final, so I'd know that's what you grade. Now that's one period of a very complex